Honorable participants, ladies and gentlemen, I would like to welcome you to the second day of the 9th ITB International I would like to welcome you today's event. You're going to be with me, day participants, ladies and gentlemen. International I would like to welcome you to remind you that this event you're going to be organized by the ITB, ladies and gentlemen. I would like to welcome you to remind you that this event, apart from that, is organized by the ITB, is going with the theme as you see. I remind you that this advancing the basic organization by the ITB is going with the best practice management, investment in advancing the basic organization. Without forgetting, yesterday it was 100 years birthday to Bandung Institute. Without forgetting, yesterday 100 birthday years Bandung Institute of Technology. Without forgetting that today's presentation we're going to have moderator that forgetting that today's presentation we're going to very important our sponsor getting very important who has been made event to be successful. We're going to very important too our sponsor getting very important first been made silver sponsor successful. We're going to very like PT our Sustraco and PT Geodipa sponsor. Apart from that also like PT our Sustraco sponsors. PT goes to PT Tunggal Buana. Apart from that also like scientific drilling our sponsor energy geothermal goes to PT others after terminal geothermal scientific energy drilling supreme energy PT Peluangka Togindo the bank Negara Indonesia the BNI bank and Peluangka PT Togindo Tunas bank Negara Indonesia but also like to acknowledge and appreciate our support Tunas bank Negara Indonesia but also like international geothermal association IGA and Indonesian Geothermal Association international and apart from that also is Indonesian Geologist Association without forgetting that this workshop has been broadcasted by our reputable media without forgetting that this workshop has been broadcasted by our reputable media without forgetting that too our Kampung News, Geothermal, Indonesian Geothermal Convention and Exhibition, Madrop Media, Rambo Energy, and the Geothermal, Indonesian Geothermal Convention and Exhibition, Madrop Media. Apart from that also, I would like to remind you more important this event is free. So apart from that also, don't forget to subscribe to our YouTube channel. Important. The link has been already shared to your chat. From that don't forget to subscribe to our YouTube. I hope everyone the link has been already shared and you not forget at the end of this event this electronic certificate will be provided everyone to you for free. And you not forget at the end of this event this electronic certificate will be provided everyone to you for free. And you not forget at the end of this event this electronic certificate will be provided everyone to you for free. And you not forget at the end of this event this electronic certificate will be provided everyone to you for free. And you not forget at the end of this event this electronic certificate will be provided everyone to you for free. And you not forget at the end of this event this electronic certificate will be provided everyone to you for free. And you not forget at the end of this event this electronic certificate will be provided everyone to you for free. And you not forget at the end of this event this electronic certificate will be provided everyone to you for free. And you not forget at the end of this event this electronic certificate will be provided everyone to you for free. And you not forget at the end of this event this electronic certificate will be provided everyone to you for free. And you not forget at the end of this event this electronic certificate will be provided everyone to you for free. And you not forget at the end of this event this electronic certificate I hope everyone to you safe and not forget at the end of this event, this electronic certificate will be provided everyone to you safe and not forget at the end of this event, this electronic certificate will be provided everyone to you safe and not forget at the end of this event, this electronic certificate will be provided everyone to you safe and not forget at the end of this event, this electronic certificate will be provided everyone to you safe and not forget at the end of this event, this electronic certificate will be provided everyone to you safe and not forget at the end of this event, this electronic certificate will be provided everyone to you safe and not forget at the end of this event, this electronic certificate will be provided everyone to you safe and not forget at the end of this event.
Speaker is Professor Tobias Fischer from New Mexico University. So we will start the presentation of our invited speaker, and after that we will proceed our technical presentation. And also please note the schedule of with the follows event rundown. So this is the curriculum vitae of Professor Tobias Fischer. He is a professor in Earth and Planetary Science, University of New Mexico. His educational background is diploma or bachelor in from Albert Ludwig University, Germany in 1991. He got the MSc in geology from Arizona State University, 1994, and his PhD degree in geology from the Arizona State University of United States of America in 1999. Now he is a professor in Earth and Planetary Science, University of New Mexico. And before we start our invited speaker's presentation, I would like to remind you all of the speaker in this technical session. There is the moment the committee will give you the memento after this presentation, and please contact the committee for the memento. Okay, now we will start our presentation or video from our invited speaker, Professor Tobias Fischer.
Good afternoon. My name is Tobias Fischer, and I will talk about gas geochemistry to advance understanding of geothermal processes. When we think about using gas geochemistry, we can think about using different techniques to understand either the source of the gases or the processes that are happening in the subsurface. On the left side, there's a summary of some of the techniques we use to understand gas source. And here it focuses on helium-3-4 ratios. On the right side of the diagram, we can use ratios of gases to understand the processes that lead to these ratios. A recent study that we did in the East African Rift illustrates the power of looking at gas sources. On the left diagram, you see that there is a map that shows you the mantle CO2 emissions measured on the craton, the Tanzanian craton, up into the rift. We see that there's a clear distinction in terms of the CO2 that is emitted on the craton versus the rift. In the lower part of the diagram, shown here, the mantle CO2 flux is very, very low, 6 grams. In the northern part, right in the rift, the mantle CO2 flux is very high, an order of magnitude higher. So that tells you that over here in the northern part, we get significant amounts of CO2 from the mantle, whereas over here on the craton, we get essentially none. We can look at the carbon isotopes and the helium isotopes to further substantiate those findings. Those measurements are relatively easy to do. With a CO2 flux meter that we put on the ground, we can measure the flux of CO2 from those different soil areas. Another example of using this technology is shown here. This is a geothermal area in southwestern Utah in the United States. Here my student Kristen Rahili has done a very extensive grid of measuring CO2 fluxes. And what she has shown is that in areas to the northwest, we have very low CO2 emissions. Essentially, it's background flux. There is no contribution of any elevated CO2 flux. However, on the other side of this fault that's been mapped in here, we can see that there's elevated CO2 flux. It turns out that on the right side of that fault, we have a hydrothermal system that brings up fluids along the fault from depth. Whereas on the left side, we're essentially looking at background CO2 without any deeper CO2 contributions. So looking at CO2 emissions by using this simple technique is quite powerful in understanding where the fluids are and where they come up from depth to the surface. However, the rest of the talk, I really want to focus on process rather than source. Now, volcanic gases sample a mixture of volatiles that come from the magma and from the surface region. The surface region is influenced by rain and by then, as a result, a hydrothermal aquifer that affects the composition of these gases. So the magma emits gases, those gases move to the surface and interact with the hydrothermal system that has mainly a composition dominated by water, but also some other gases like CO2 and methane and so on. So complex reactions happen in this system. And when we try to understand the processes that are occurring, we can focus on a few of these gas species. So hydrothermal gases are low temperature gases. And here's an example table of hydrothermal gases. You see that the temperatures are all below boiling, essentially. Here, for example, is Papandayan in Indonesia. And we see that these gases are dominated by water, CO2, and in terms of sulfur species, by H2S. There's very little chlorine, there is essentially no fluorine, and there's some hydrogen, some methane. And if we go to the next slide here, we see that there's also very little CO, and we have certain ratios that determine whether we have air or air-saturated water or different carbon isotopes. So there's a lot of things we can measure and investigate when we look at hydrothermal gases. In order to understand these processes, we can focus on some key redox relationships in those gases. While we have this overwhelming compositional variety, we can focus on a few species that are helpful when we try to understand process. So some key redox relationships are shown here. Water going to hydrogen and oxygen, CO2 going to CO and oxygen, CO2 and water going to methane and oxygen. So those are some key reactions of the hydrogen and carbon gases. And for each of these, we can write an equation that involves the equilibrium constant. So in this case, we consider equilibrium in a single vapor phase. Then we can manipulate these relationships and we can solve for the fugacity of hydrogen, the fugacity of carbon monoxide, and the fugacity of methane, for example. And we can see that these fugacities are related to the equilibrium constant, again, of the reaction, and to the oxygen fugacity and the water fugacity in almost all of these reactions, you see. So the fact that we have redox relationships is really important. It determines what the gas composition is going to be that we will sample at the surface. And we can then use these kinds of relationships to make a diagram like this. And this is a very famous diagram. It's been around for a long, long time. And what it essentially shows you is the fugacity of these gas species depending on temperature. So temperature is high to the left, 300 degrees, 100 degrees on the right. And we see, for example, that the fugacity of water decreases as the temperature decreases, fugacity of CO2 decreases as the temperature decreases, fugacity of methane goes up, and hydrogen goes down. CO, for example, has a very low fugacity, and it also decreases with decreasing temperature. So this diagram is helpful to understand what the relative abundances of these gas species are in equilibrium. And there are two different lines here. One is Ligenbach's 1987 relationships in solid lines, and D'Amore and Panici's line in dashed lines. So slight differences in the distribution, but overall, this would be an equilibrium distribution for these types of gas species at different temperatures. However, in volcanic gas and geothermal gas geochemistry, we cannot determine the individual gases or the individual fugacities for fumarolic gases. So by fumarolic gases, I mean gases that come out of gas vents. So we can't really compare the figure that I just showed to use as a comparison of theoretical values to actual samples. Now we can get around this very easily, and this has been recognized by Ligenbach and co-workers by simply using gas ratios. And so through a lot of research and work, people have established some key gas ratios. And so what I show here are some of these key gas ratios, right? So the log X water to or hydrogen to water ratio is an important one. And it essentially relates to the fugacity through that, relationship with the equilibrium constant. So in this diagram, we see that we have the relationship between hydrogen and water, CO and CO2, and methane CO2. So these three ratios are really key when we try to understand the processes that are happening at depth. And again, you notice here that I'm only showing hydrogen, carbon, and oxygen gases. Sulfur gases are not included in this assessment for simplicity. Now, when we utilize those relationships, we can make plots like this. And what you see here is a plot of the logarithmic relationship of hydrogen to water and CO2. And we can calculate these vapor lines and the liquid lines, and I'll show in the next diagram how that is done. And once you have that, then you can plot your data, because your data, your samples are analyzed for hydrogen and water contents and for CO2 contents, amongst all these other gas species that you might want to analyze for. And what you see then here is a number of data points from many different volcanoes all over the world. For example, we have Tambora here from Indonesia, right? And we can then plot it on this diagram. And you see that if some some data point plots right here on the vapor phase, then that implies that this gas originates from a vapor-dominated system at depth. And then the question becomes, well, what is the temperature of equilibrium at depth? And you can read that off of this diagram, right? So in this case, it would be about 150 degrees C. Now, if you have a sample that plots closer to the liquid line, for example, these I data points here, those are from Ischia in Italy, then that implies that the origin, the source, and the process of that sample is a liquid-dominated system at depth somewhere. We don't know exactly where that liquid is, but we know it's there somewhere at depth. And that gas comes from the equilibrium with that liquid phase, and that liquid phase has a temperature of 300 degrees C. Now, any samples that plot in between those two are likely a mixture between a vapor and a liquid-dominated reservoir. So this analysis is really useful in understanding the processes as well as the source of those gases. And they give you an idea of where the high temperature reservoir is and whether that reservoir is liquid or vapor dominated. Now here, I just show how you can make such a plot. What you need to do is you have to have, for example, an equation like this that allows you to calculate the vapor log H2H2O with this equation. So it relates to temperature here in Kelvin, which you can easily convert to degrees C. And then you can make the plot here for different temperatures. So each temperature corresponds to a different hydrogen-water ratio. For the liquid part, it's a little bit more complicated, but essentially you will have to have the liquid vapor distribution coefficient to compute the coexisting liquid. And those vapor liquid distribution coefficients are available in the literature. So you can essentially calculate the liquid and the vapor relationships yourself, make a diagram like this, and then you can simply plot your data points from your samples on this diagram to establish what your source and your process is at depth. So I've shown you how we can use CO2 flux and gas chemistry to establish where there are fluids coming from depths, what the temperatures are, what the source is in terms of liquid or vapor, and where most of the flux would be coming up. So these are methodologies that can be easily deployed by collecting samples in the field and doing some relatively straightforward analyses of these samples. Of course, we can extend those analyses to include isotopes and trace elements for even more detailed information on these geothermal and hydrothermal systems. Thank you.
Okay, very nice video presentation and very great lecture from Professor Tobias Fischer. So even there is no direct question and answer from the audience here, but all our audience, you may send your question in the future Zoom using chat or question and answer, and also some comments. You can give comments in our YouTube link of this presentation for this technical session. So even there is no question and answer, I have some notes from Mr. Tobias Fischer presentation. Very beautiful and nice presentation related with the gas geochemistry. He presents some his research related with carbon isotope and helium-3-4 ratio to see the source of gases in the rift zone or craton zone and the rifting process, and also the reaction related with the redox surface process is very complicated, but he can show us how to analyze the process using some gas geochemical analysis. And some notes also related with the gas fugacity is very important to see the origin and process of gas sources and process related with the hydrothermal aquifer to present in the shallow depth. And also the abundance of gases related with the equilibrium. He showed us the example of using fugacity of hydrogen and water ratio, and also CO and CO2 ratio to determine the temperature in equilibrium phase of each our sample gas. And he also give us some notes. This gas geochemistry analysis can be combined with other geochemical techniques and isotope analysis. And all of his presentations maybe we can use in our research and our works to see the result of geothermal energy. Okay, that's some notes from me. Maybe you can, I will remind you again, you can send your question in chat or Q&A in Zoom or in YouTube link. Okay, now we will continue our technical session with some paperwork from 6 speakers. First, Ms. Vita. Yeah, Ms. Vita. She will present his research. This is CV. He's got a bachelor degree in geological engineering from Gajah Mada University and master program in geothermal engineering Bandung Institute of Technology. Now he is the master student in master program of geothermal. She works at Chevron Geothermal Indonesia, start from 2008 until 2009. And he is the development of geologist and geomodeler of Star Energy Geothermal Salak, start from 2015 until now. So Ms. Vita, time is yours. Your time for presentation is 15 minutes. And then there is 5 minutes for question and answer. You, all audience can send your question in Q&A feature in Zoom, or you can write in YouTube comment. Okay, Ms. Vita, time is yours.
Good afternoon, everyone. Thank you for the opportunity given to me. Today, I would like to share my paper about geothermal prospect review in the western part of Salak Volcano, West Java, Indonesia. First of all, I would like to thank Star Energy Geothermal Salak for granting permission to publish this work. Massive thanks to Pak Yudi and Pak Glenn as my supervisor, and also Ibu Suryantini for reviewing my paper and for your valuable feedbacks. The topics that I'm going to present is actually an ongoing study, so I really appreciate for any comments and feedbacks for my presentation. This is the outline of my presentation today. I will start with introduction, background and objectives, geology, geochemistry, geophysics, conceptual model, and conclusion. Star Energy Geothermal was established in 2003 as an independent national energy company whose operation bases are mainly in Indonesia. Currently, Star Energy Geothermal operates 3 major geothermal fields in Indonesia, namely Wayang Windu, Derajat, and Salak, with total capacity of 875 megawatts. The Salak geothermal field is currently the largest geothermal producer in Indonesia with an installed capacity of 377 megawatts. Commercial production at Salak commenced in 1994, and currently there are 6 power plants units. The location of study itself is at the western part of Salak volcano, southern Bogor district, West Java province, Indonesia. Gunung Salak, with elevation about 2,200 meters, is a prominent stratovolcano located in the Quaternary volcanic front of the Sunda Arc in West Java. This slide shows the background and objectives of this study. The area of interest that we called as Kawah Ertankian is a vigorous fumarole area with numerous superheated and boiling steam vents, boiling acid sulfate hot springs, and large areas of acid-altered ground. Extensive geological, geochemical, and geophysical surveys conducted in 1982 to 1983. However, none of current Star Energy resource management involved in Ertankian exploration. The objectives of this study is to revisit Ertankian field data and conduct thorough evaluation of geologic, geophysics, and geochemistry to provide alternative conceptual model and proposition of further study or future action item. From this topographic map, we can observe that there are several prominent eruption centers, the Gunung Salak itself, Gunung Gagak, Gunung Perbakti, and Gunung Halimun, and also Cianten caldera at the west part. The Salak volcano is the largest and most easterly cone in the Salak Perbakti Gagak volcanic massif as a product of late Pleistocene to recent stratocones, parasitic vents, and phreatic craters. The Perbakti Gagak range to the southwest is strongly eroded. Both areas in the northeast and southwest are sites of extensive hydrothermal activity. Intermittent volcanism occurred at Salak between 200,000 to 1 million years ago. In historic time, volcanic activity at Salak has been limited to a number of phreatic explosions occurring at the side vents on the flanks of the volcano. The summit area of Salak is characterized by 2 large bridge craters, one open to the northeast and another to southwest, which are associated with volcanic sector collapse events. And the westernmost crater was the source of large debris avalanche deposits, which extends over 10 kilometers from the summit. A late-stage dome built on the western crater rim as a result of the most recent activity. From this regional geology map, we can observe that there are 2 major volcanic products came from separated eruption source, the pre-Salak volcano and Salak volcanic products. Pre-Salak volcano consists of andesite lava of Gunung Menyan, old volcanic deposit at the southeast, andesite lava of Gunung Endut Perbakti, and lahar deposit at the northeast. The volcanic products itself consists of 4 episodes of lava flows from Salak volcano, pyroclastic airfall deposit, which consists of scoria and pumice, Gunung Sumbul lava flow, lava dome, several lahar deposits, and phreatic avalanche deposit in the northeast. This map shows closer look to the study area. And Kawah Ertankian is a vigorous fumarole area, contains numerous superheated and boiling steam vents. Sulfur is deposited around many of the vents. The gas in fumarole area relatively high NCG, above 4% weight, and high H2S, above 6% mole. 2 dominant fracture trends are present in the area of interest and has a strike of northeast-southwest and northwest-southeast. These dominant fracture trends are also found in the commercial Salak geothermal field. The Salak Pelabuhan Ratu regional fault, which has trend of northeast-southwest, extends more than 7 kilometers south of Salak volcano. This is relatively parallel with the Salak volcano sector collapse wall. The northwest trending fractures intersect the northeast set in the vicinity of the Kawah Ertankian. This structural intersection may well have controlled the location of the Ertankian hydrothermal system. The northwest trending faults appear to channel shallow outflow and surface discharge from the hydrothermal reservoir and may also constitute boundaries of the deep reservoir. Another prominent alignment is the northwest-southeast trending Perbakti structure, an infer fault located between the Salak geothermal field in the west and the Ertankian geothermal prospect in the east that could have an important role for the Salak and Ertankian geothermal fields. The Ertankian hot springs has acid sulfate character and yields little information about the underlying hydrothermal system. The ternary plots show spring samples from Ertankian, Zeta, Beta, and Gamma thermal manifestations. From chloride sulfate bicarbonate ternary indicates that the Ertankian spring is typical of sulfate, Zeta is chloride, Beta and Gamma springs are mixed bicarbonate chloride waters. While from the ternary of natrium, potassium, and magnesium, it shows that all springs are immature, while Zeta, that believed as the best representation of liquid level of the Salak geothermal system at surface, is the only one in partial equilibrium state. A significant aspect of the Ertankian fumarole chemistry is the stable isotope composition of steam condensate. The Ertankian steam contains much heavier hydrogen and oxygen than local meteoric water, indicating a significant non-meteoric component in the reservoir fluid. The presence of the non-meteoric component implies a strong flux of the component into geothermal reservoir relative to meteoric water influx during the historical life of the system. Possible origins of the thermal fluid are old formation water and or magmatic water. This slide shows the gas geochemistry of the Ertankian surface thermal manifestation. So majority of Ertankian gas is related with high temperature deep upflow as plotted in this part, while Zeta hot spring show a mixing line with air saturated water. And from this ternary plot, majority of Ertankian gas plotted in the H2SN member, while Zeta and Sigit reflects almost pure carbon dioxide as typical peripheral fluids. A geophysical survey was conducted in 1983 in the area of interest during the exploration. In this survey, magnetotelluric stations were distributed around the broader prospect area toward the east region of the prospect in the vicinity of Kawah Ertankian area. Although the survey was conducted with a wide coverage, a number of the magnetotelluric stations were not used because of the low signal to noise ratio and absence of a static shift correction on the data. In 2004, another MT survey coupled with time domain electromagnetic or TDEM measurement was conducted. However, the survey mainly concentrated in the Salak production area and did not give significant improvement to the data coverage in the eastern portion of the Ertankian prospect. An extensive area of low resistivity is distributed across most of Ertankian prospect area. Low resistivity zones are found around the Ertankian thermal manifestation complex and broaden to far northwestern warm spring in Beta and Gunung Perbakti in the southwest. These low resistivity zones can be due to several types of clay-rich deposits such as volcanic clastic clays, sedimentary basin clay deposits, or smectite argillic clay alteration overlying a geothermal system. Within the Ertankian prospect, the low resistivity layers that are near to and appear to be associated with surface thermal manifestations are believed to most likely represent the signature of a clay cap over a geothermal reservoir or outflow from a geothermal reservoir. A standard way to view the characteristics of the low resistivity layer is to contour the elevation of the base of conductor layer. In the case of Ertankian, the elevation of the base of less than 10 ohmmeter layer was determined from the 1D empty models from each of the empty stations. The figure shows that the shallowest base of the conductor is observed in the area near the Ertankian fumarole and possibly extends to the northwest towards the alpha well or A-3 well area. Towards the south and southwest from Ertankian, a significant deepening of the base of the clay cap is observed. However, there is minimal information to describe the area east of Ertankian thermal area, as the latest empty stations were located west of the Ertankian prospect. In addition to the information from the base of the conductor, the total conductance map shows the highest value is in East Ertankian thermal area, although there are not many empty stations in this general area. The higher conductance region indicates higher intensity of conductance and trends in a similar northwest-southeast direction toward A-3 well as the trend of the shallow conductor. The observed resistivity trends parallel to the northwest-southeast oriented south and north Ertankian invert faults, which probably act as pathways of the outflow of the system. Several cross-sections were constructed to illustrate the subsurface distribution of the clay cap at Ertankian to determine the possible aerial extent of the prospect. However, due to limited time, I will only show one example of the cross-section. The Ertankian -2 profile, which passes along the Vita hot springs and extends through the Ertankian fumarole towards the southeast, shows a continuous semi-flat conductor that extends from Ertankian to the northwest and possibly delineating the outflow of the hydrothermal system. The extension of the clay cap towards the southeast is unconstrained because of the lack of empty stations. Because of the distant station shows weak conductance. This slide shows the initial conceptual model of the Ertankian area. So the integration of geology, geochemistry, and geophysics data are used to develop the conceptual model of the Ertankian prospect. From the data that integrated, the interpretation is that the invert outflow located beneath Ertankian fumarole and outflow towards to the northwest to the Beta hot spring here. Prominent northwest-southeast invert faults appear to control the permeability and outflow location, as indicated also by base of low resistivity, which is shallowing to the east and distributed to the northwest-southeast trending, follow north and South Ertankian invert faults. This would be my last slide. So the conclusion from this study is that the integration of geology, geochemistry, and geophysics data indicate that geothermal potential significance may exist in the Ertankian area. The invert outflow located beneath Ertankian fumarole and outflow is interpreted to the northwest in the Beta hot spring. Numerous superheated and boiling steam vents exist in this vigorous fumarolic area with some sulfur deposit. The fumaroles are typically high gas and high H2S with no indication of excess chloride from its steam condensate. However, the data shows that there is indication of geothermal fluid with magmatic input. Prominent northwest-southeast invert faults appear to control the outflow location, as indicated also by base of low resistivity, which is shallowing to the east and distributed to northwest-southeast trending, follow north and south Ertankian invert faults. Lower conductance value and deepening of clay cap base to the southwest direction indicates lower possibility of connection to Salak reservoir system. In view of the fact that phreatic explosions have occurred in the last 50 years, a detailed study of potential hazard should also precede any major development. So that's all for my presentation. Thank you. I appreciate for any feedback and comments.
Okay, thank you, Ms. Nurvita. it's very nice presentation and results. Now we have a question and answer session. There are two questions. First, from Mr. Dennis Mutebi from Pajajaran University. He asked, could you or what depth or elevation correspond to the zone of empty maps? So you shown us the empty maps. That's his question. And the second question is from Mr. Mulyanto from Pertamina Geothermal Energy. Based on the anion ternary plot, it shows that Ertankian samples have chloride content. How significant is the contribution volatile magmatic in the system? Or resistivity data also shows thicker conductive layer in the upflow. Is that correlated with the acidic fluid alteration? So that's the two questions. There are third question from Uni from ASDM. How about lithium, chlor, and boron concentration to determine the origin of fluids? Whether the fluid in the Ertankian prospect area is the same reservoir as the Salak area or surrounding area. Thank you. There are three questions. Or you may answer now.
Thank you, Pak Irwan. So I will answer the first questions. So it's about the depth of the elevation correspond to the empty maps. So actually from the empty maps that the base of low resistivity layer or the base of conductor, the shallowest of the elevation is about 600 meters at the center part of Ertankian prospect area.
Okay. So that's the first question. You answered the first question, and the second question from the ternary plot is so have a chloride content. How significant is the contribution of volatile magmatic in the system?
Actually, the chloride from the Ertankian hot spring, it's not really that much. The chloride content that major or significant is actually from the hot spring of Zeta and Beta. So Zeta is at the northwest of the field or north part of the Salak geothermal system, and Beta at the northwest of Ertankian. So the chloride is majority found in Zeta and Beta. For Ertankian itself, the majority, the chemical component is sulfate.
Okay. Okay, nice answer. And also from Mr. Mulyanto, the resistivity data shows the thicker conductive layer in the upflow zone. Is that correlated with acidic fluid alteration? Yeah, the thickness, that conductive layer in the upflow zone is thicker. Is that correlated to the acidic fluid alteration?
Actually, at the surface thermal manifestation or the Ertankian fumarole, the conductive layer shows very high, or the shallowest part of that area. So it's not really that thick compared to the margin of the area.
Okay. Okay, from Miss Yuni from ESDM, how about the lithium, chlor, and boron concentration to determine the origin of fluid? Is it the same fluids from the same source as Salaks and or surrounding area? Is that the same reservoir or not? Usually we use the lithium, chlor, and boron.
When I compare from Salak thermal manifestation and Ertankian, looks like that it's not the same source. So the Ertankian and the Salak geothermal field is not came from the same source.
Okay. Okay. That's the third question, but Mr. Dennis Mutebi asked you to show you each map that tell us the depth of elevation from which the map was obtained. The resistivity varies with depth. Maybe Mr. Dennis Mutebi can directly ask to the presenter for the presentation, more detail, right? More detail you can discuss again related with your result, very detailed questions. So are there any comment and or question from the audience? We have 1 or 2 minutes. I have one question for you. The Ertenkian hot spring is acid spring, right? Acid water. Is it right? With the low pH value?
Yeah, Pak.
Yes. Is it the steam heated water?
Yeah, I think it could be steam heated water, Pak.
Okay. Yeah. And my short comment is you mentioned in the conclusion part, you use the helium-3 isotopic ratio, but I couldn't find in the previous data. But you also show us the oxygen and deuterium isotope ratio. But for the helium isotope ratio, I could not find the result, but you concluded. But maybe you missed it. Maybe we can, you missed this one. Okay. Very nice presentation, question and discussion. And we can close this first technical session from the first presenter, Ms. Nurvita. We may give Ms. Nurvita a big applause. Okay, thank you, Ms. Nurvita. And then before we start the next presenter, the second presenter of this technical session, there is a short video from our honorable sponsor from Sustraco.
Geothermal energy is a relatively environmentally friendly source of energy. It is derived from the heat of the earth. In recent years, the market for geothermal power has increased sharply, especially in emerging markets due to the economic growth due to the growing number of communities in low-income rural areas that have access to the power grid. Any governments are also increasing focus to reduce the dependency on expensive fossil fuels and not environmentally friendly. Sustraco Group is a company engaged in the energy sector. Established in 1995, Sustraco Group is currently very focused to be able to develop and serve you in various needs related to the geothermal sector, which among of them are hole cleaning services. Sustraco Group provides comprehensive conventional fishing tools and systems include packer milling and retrieving, internal and external cutting, internal and external engagement, washover, basically every fishing application. Regardless of what's in your well, hence we've removed it successfully. We also provide a radial cutting torch that is safe and without any explosives or harmful chemical elements that can cut the tubular drilling equipment left in the well. As well, biochemical that can scale control, corrosion control, cooling water treatment and also as a rig washer. Downhole camera. Leveraging the advancement of technology today, Sustraco Group also provides high-resolution downhole camera equipment and clear image quality and capable of operating up to a depth of 2,000 meters, adding to our line of services to focus on the development of the geothermal sector. Geothermal well testing. Energy Mega Perseda as the sister company of Sustraco Group also provides the services of geothermal well testing, real-time well monitoring, geoscience. Digital remote sensing used sniffer 4D drone. Digital remote sensing system has an advanced capability to detect and map for the following energy sector applications: steam surface breakout monitoring, well reliability and integrity monitoring, air quality mapping, well surveillance and inactive well management, geothermal associated gases detector and mapping. All of which are focused to support activities in the geothermal sector. Please Do not hesitate to contact us when you need our support, because we are there for our common progress. Thank you very much.
Okay, ladies and gentlemen, thank you for your patience, and we will continue our technical session. The second presenter, the second speaker is Mr. Mauliate Sihotang from Supreme Energy. So Mr. Mauliate Sihotang, now he works as a development geologist for Supreme Energy, start from 2013 until now. Okay, we can start the presentation from Mr. Mauliate Sihotang.
Good day, everyone. My name is Mauliate Sihotang. Today, I would like to present my paper that entitled Geology Controlling Factors of the Top of Reservoir Muara Geothermal System Case Studies. This is the presentation outline. Muara Geothermal System is located about 135 kilometers southeast Padang. The company started to explore since 2008, and in 2019 we are successfully conduct COD with a maximum net capacity of 85 megawatt electric power plant. We also operate in South Sumatra with Supreme Energy Rantau Dadap that's currently in power plant construction process. The last field that we operate is in Lampung, is called Supreme Energy Raja Basa, which currently still conducting exploration. This is the geology of Muara Geothermal System. The system is located in the Great Sumatran Fault step over between Suliti segment, Siluak segment, creating a pull apart basin. The system is closely related with Mount Patah 9 volcanism. The oldest volcanism is Mount Bangko, and it becomes younger toward southeast to the youngest volcanism in Mount Kerinci. The structure within the system is trending northwest-southeast, following the Great Sumatran trend, and we will see the alignment of the manifestation following similar trend. From surface mapping and well data, we also observe the north-south trending and the northeast-southwest trending fault that become our permeable structures. We also observe in the northeast part an outcrop of basement rock, the Barisan formation, and the pre-tertiary intrusive that may act as our system basement and boundary toward east. In terms of top of reservoir in geothermal system, the top of reservoir bounded the reservoir system section in beneath, and the non-reservoir sections above it. The definition is quite varies depending on the development stage. During exploration, we conduct a conceptual model to predict the top of reservoir, and after drilling exploration well, we refine it, and after having the completion test, that we also refine the top of reservoir definition based on temperature data. So every company have its own definitions on the temperature target that needed, and the permeability indicators that being used. In terms of the objectives, is we want to set our production casing quite close to the top of reservoir to maximize the productivity of the well, because we don't want to set it too shallow that may harm us with a cooler influx, or too deep, so we are puncturing the reservoir where the cementing operation will be difficult. So in Muara Labuh, we use the same process. We monitor the rock, the alteration, and the force of coherence of epidot as our indicator. We also observe whenever our MEB is dropping to below 10 and 5, we are getting closer to the top of reservoir. We see that whenever we have a MWD temperature reaching 55, more than 55, and the delta T of the temperature is more than 6 degrees, we are getting closer to the top of reservoir. We have an objective to set PCS about 30 to 50 meters above the top of reservoir. After well completion, this data will be refined by PT data. Our temperature target for this field is higher than 230 degrees C with convective temperature profile. This is the northeast sector. So in general, the production sector is divided into two. The northeast sector, where the steam cap wells located, the top of reservoir is relatively shallow. We use all the data, the geology, the wire and log data, the XRMI log, the image log. We also see the textural and also the thin section XRD data. So in the northeast sector, represented by IA3, the top of reservoir is around 650 meter measure depth. We set the PCS about 631 meter. So it's around 20 meter to 19 meters gap from the PCS to the top of reservoir, which is relatively good. The top of reservoir itself sits in the lower part of Vita 9 unit, and we see that our major entries are located in the different undifferentiated silicic formation. It's kind of composed of rhyolitic to dacitic silicic volcanic. We also see a chance of alteration. The MEB is kind of getting lower than 10 since 621, getting closer to the top of reservoir. The top of reservoir itself located in the transition alteration zone that consists of mixed layer clay, smectite composition with chloride. We also observe that in the area, the major vein species is composed of calcite and quartz. This is the thin section of the lower Vita 9 underside. This kind of showing a lava-like underside with a chloride and quartz vein. We also see a vein in MLA2 in the northeast sector, composed of calcite, wyrite, and anhydrite. This is anhydrite and wyrite. From the image log, we see that near to the top of reservoir, we see some kind of brecciated possibly a contact between more massive lava like rock interval in the above part and relatively layered interval beneath it. So we move on the southwest sector. The top of reservoir is located in the deeper level, is around 300 meter elevation. We sight the PCS at around 990 meters. It's relatively quite far from our expected top of reservoir. The top of reservoir itself located within the intercalated andesite and dacite unit. We also observe similar lithological sequence in the shallow level, but no permeability to occur at this particular section. We see the vein characteristic proximate to the top of reservoir location is composed of calcite sericite vein that cross-cut the early epidote vein within this area. And after conducting the study, we see that the late epidote vein is being encapsulated or cross-cut by calcite and anhydrite, meaning that it's possibly that in the past time it encountered a boiling process. So continuing to the thin section of the intercalated andesite and dacitic interval, this is a porphyritic dacite. We see kind of being altered with silica and chloride. In terms of vein characteristic in the shallow part near the top of reservoir, we see that the epidote vein is being covered or encapsulated by quartz and calcite. Compared to near to the pit zone, we see a epidote vein that has that occurs in the open space that still have major permeability with some calcite occurrence after the epidote vein. So comparing all the data between the northeast well, A3, A2, and H1, and the southwest sector wells, H4 and H2, as we can see that the southwest sector have similar lithological sequence like the northeast sector, but the permeability in the shallow part is being blocked by later calcite and anhydrite mineral that potentially block the distribution of the shallow reservoir in this part. And after getting closer to the top of reservoir, the permeability seems to improve, and we also see that the vein still showing intergrowth of epidote, a lot of open space. Tim Stimek in his paper suggests that the observation is caused by a rapid boiling process in the later episode that block all the permeability within the shallow area that make the interval is not that permeable. Looking at the cross sections on the northeast sector in the north and the southwest sector in the southwest, we can see that the top of reservoir is shallower in the north and become more deeper in the south. We can see that the top of reservoir in the northeast is composed of transition alteration zone because of the deposition of calcite. The permeability is not continued toward the southwest sector in the shallow part section, but still the permeability in the profilytic alteration still develop, and we still have a good permeability in this part of the area. So a summary, top of reservoir definition is varies between operators and stage of project development. We see that the northeast southwest sector, top of reservoir, is shallower, located within the patah 9 underside, close to the contact, and we see that the observation is a transition alteration. We see that in southwest sector, we found a similar shallow stratigraphy like the northeast sector, but not much permeability. It's located in the intercalage dacite and andesite unit with profilytic alteration. In terms of vein, the northeast sector have calcite quartzite as a dominant vein species, possibly related with the steam cap existence, and more epidote, calcite quartz, and saricite in the southwest sector, kind of suggesting that this is, and confirming this is still a liquid-dominated productive zone. In terms of the reason why that the southwest sector is more deeper, have a deeper top of reservoir, possibly the permeability destruction due to calcite and anhydride deposition. The interpretation is the rapid veiling process due to the sector collapse that deposit or make the deposition process is very intensive in the shallow southwest sector. That's all my presentation. Thank you, and we'll be glad to see our discussion. Thank you very much.
Okay, it's very nice presentation and results from Muara Lobo project conducted by Supreme Energy, presented by Mr. Agus Mauliate Sihotang. It's very nice presentation, and we will start the question and answer. If some technical problems occur during this question and answer, especially when internet problems occur, please maybe some answer will be typed directly to the audience. But I will read the first question is from Panji Star Energy. The question is, which type of geothermal system in Muara Laboh? Is it distributed permeability or fault system? Any distinct fault or structure playing role in permeability in this field? That's the question. Maybe Mr. Agus Mauliate can answer the first question.
Okay, thank you, Pak Irwan. Because the location of Muara Laboh geothermal system is located within or in the center of Great Sumatran Fault, fault control will be one of the major permeability generators. After looking at all the data, we see also connection between specific permeable interval or contact between units that can enhance the permeability within the resource. Like in the northeast sector that I mentioned before, the contact between the patah 9 underside with the undifferentiated silicic unit provide a good distribution lateral permeability within the field. For the software sector itself, because we in the intrusive environment, the contact between intrusive complex, young intrusive complex with the host rock can be older volcanics or older intrusives, also can enhance the permeability within the resource. Maybe that's all, Pak Irwan. Thank you.
Thank you. Very good answer. And the second question from the audience is from Mr. Vicky or Miss Air from Geodipa. How is the correlation of reservoir which interpreted from alteration minerals and from PTS survey?
Okay. So before or when we are drilling, we will use the temperature sensitive minerals like smectite, elite clays, and try to see whether we have a evident occurrence that can give a sense of temperature at that particular depth. But we also refine it with the temperature data later on, so we can get more robust indicator. In this paper, actually, in the northeast sectors, the correlation between smectite decrease that we identify from MEB index, the alteration change that we see from the rock cuttings, and the base of conductive of 5 meters is relatively correspond with the actual top of reservoir. More complex situations we observe in the southwest sector, but whenever we see a euhedral episode within more andesitic to desitic rocks, we actually have or use that as a guide, which also correspond with the pressure, the temperature data. Yeah, Pak Irwan.
Okay, thank you. There is another question from Mr. Nul Hoiri Amin. How to control the scaling issue at the downhole system? That's very short question, but
okay, scaling issue is kind of different from the topics, but I try to answer, Pak. But if you notice that the scaling, especially silica, will be correlate with the resource temperature itself. If our problem is silica scaling, temperature and component of the reservoir rock. So to kind of mitigate it is to try to see whether what is the silica saturation index or calcite saturation index, or you have a while drilling you can see that your reservoir rock component is rich in calcite or rich on silica, so you can mitigate how you will extract the resource, how you maintain the scaling problem in your wellbore. Maybe that is the short answer for that.
Okay, so we still have 1 minute for question and answer, but I have one short question. So you mentioned that there is a different kind of mineral between northeast and southwest sector, right? What is the main control of the situation? Why it happened?
Yeah, I think the
okay, maybe the problem.
Or paint characteristic is quite different. It's representing more steam environment, so we see a calcite paint, anhydric paint that still have a good permeability, but kind of cross-cut or overprinting the later epidot vein. So if we compare to the southwest sector, that kind of a more liquid-dominated reservoir, quite hot, we kind of seeing that it's more dominated of open space epidot vein occur within the reservoir itself. So it's kind of a and different temperature where northeast is kind of a 235 to 240 degrees C compared to more than 270 degrees C liquid resource in the southwest sector. That's all, Pak Irwan. Thank you.
Okay, thank you, Pak Agus Mauliate Sihotang. So that's very fruitful discussion from this technical second presentation in this technical session. We give applause for the Mr. Agus Mauliate Sihotang. And then before we continue to the next speaker, third speaker in this session, we will see the video of our honorable sponsor from Geodipa. Thank you.
Indonesia merupakan salah satu negara yang memiliki potensi energi panas bumi terbesar di dunia. Saat ini, Indonesia menduduki peringkat 2 dunia sebagai negara penghasil listrik dari energi panas bumi. Selain sebagai energi yang bersih dan berkelanjutan, peran energi panas bumi sebagai baseload penyediaan listrik menjadi pertimbangan utama agar pengembangannya diprioritaskan. Oleh karena itu, dalam menjaga ketahanan energi suatu negara, energi panas bumi dapat menjadi andalan untuk memasok listrik guna memenuhi target bauran energi 23% EBT di tahun 2025, sesuai dengan amanat dari Kebijakan Energi Nasional. Untuk memenuhi pencapaian target EBT, dalam bauran energi tersebut, Indonesia layak melakukan percepatan pembangunan proyek PLTP di Indonesia. PT Geodipa Energi Persero adalah perusahaan yang bergerak di bidang energi panas bumi mulai dari eksplorasi hingga eksploitasi. Perusahaan didirikan pada tanggal 5 Juli tahun 2002. Kemudian pada tahun 2011, melalui Peraturan Pemerintah Nomor 62 Tahun 2011, Geodipa ditetapkan sebagai Persero yang pengawasan dan pembinaannya berada di bawah Kementerian Keuangan dan PT PLN Persero, yang juga merupakan salah satu Special Mission Vehicle atau SMV di bawah Kementerian Keuangan dengan misi mendukung program pemerintah dalam penyediaan listrik tenaga panas bumi yang aman dan ramah lingkungan, serta memberikan manfaat besar kepada Indonesia. Geodipa siap untuk melanjutkan pengembangan proyek PLTP Dieng Patuha yang masuk dalam Fast Track Program atau FTP tahap 2 10.000 MW. Bagian dari program 35.000 MW yang merupakan program pemerintah di bidang pembangunan infrastruktur ketenaga listrikan.
Okay, thank you, ladies and gentlemen. We will continue for the next speaker. The next speaker is Mr. Sigit Suryanto from Pertamina Geothermal Energy as the third speaker of this technical session. So, Mr. Sigit Suryanto, his curriculum vitae, he worked in Pertamina Geothermal Energy. And this is the CV, he got a bachelor degree from geology. So, start from 2009 until now, he worked as a geologist at PT Pertamina Geothermal Energy. We can start our presentation from Mr. Sigit Suryanto. Time is yours.
Good afternoon, everyone. My name is Sigit Suryanto. Today, I am going to give a presentation for our research with the title Integrated Geoscience Data to Identify Heat Source Beneath Ume Volcanic Complex in Tompaso Geothermal Field, Indonesia. This paper was written by me as author, and co-author are Pak Tovan Sastranegara, Pak Antonius Risanguntoro, Pak Nanda Najih, Pak Ristio Effendi, Pak Imam Baru Raharjo, and Ibu Suryantini. In this paper, I will explain how to determine the location of the heat source based on the geological data, geophysical data like resistivity from MT and gravity, geochemistry data from the isotope like deuterium and oxygen-18, and pressure and temperature from the borehole. Heat source is very important in a geothermal system because the heat source always supports heat to the fluid in geothermal reservoir. The location of the heat source is very important to know because common related to the main outflow zone or main prospect zone in a geothermal system. Outline from this presentation is divided to 7 parts. Number 1 is background, number 2 location, number 3 geological map, number 4 resistivity and gravity, number 5 isotope, deuterium and oxygen-18, number 6 pressure and temperature from the borehole, number 7 conclusion. This is the background from this research. The location of the heat source is very important to know. An approach, geologic setting, remote sensing, resistivity and gravity, isotope, and temperature measurement from the wells can predict the location of a heat source. This method can be used to make sure the location of the heat source, especially in Tompasso geothermal field. The purpose of this research to support update conceptual model of Tompasso geothermal field. The Tompasso geothermal field is located in Tompasso district, Minahasa Regency, North Sulawesi Province, Indonesia. Tompasso geothermal field is apart from Lahendong working area or 30 km southern part from Lahendong geothermal field. Lahendong geothermal field around here. Geologic setting from the Tompasso geothermal area is related to the caldera system. The youngest volcanism rise up in the caldera wall. In this map, we can see the Monsoputan. Monsoputan is the recent volcanism related to the recent subduction zone in the Molucasi or in the eastern part from the Tompasso geothermal field. Around the Monsoputan, we call the Sempu volcanic complex around here, was interpreted as the main heat source of Tompasso geothermal field. This is a geological map from the Tompasso geothermal field. In the southwest area, we can see the Monsoputan, and this is the Sempu volcanic complex, and this is the main focus area in this research we call the Umeh volcanic complex. The remote sensing data shows that some lineament like structural geology, Toraget Totolan fault, Soputan fault, and others geological features. In this map, we can see the circular feature in the top of Mount Umeh. Circular feature is usually related to the center of the volcanism, and the yellow one is Umeh volcanic complex. Umeh volcanic complex was interpreted like monogenetic volcanism, which rise up among the Tondano explosive product, the pink one. There are several manifestations around the Umeh volcanic complex. We will discuss later in the next slide. This is the resistivity and gravity data section from the southwest to the northeast. Based on the resistivity data, we can see the updoming pattern beneath Umeh volcanic complex. And if we compare to the gravity data, there is a high gravity anomaly. High gravity anomaly common related to the intrusion body or rock has high gravity value. Present updoming pattern and high gravity anomaly in the same location beneath Umeh volcanic complex. It's make possible in this location has additional heat source. This is graph from Ghilman 1992, showing the ratio between oxygen-18 and deuterium. These isotope data were taken from the geothermal manifestation in Tompasu geothermal field. We can see, plot the TPS1 and TPS8 shifting to the magmatic zone. The location of the TPS1 and TPS8 around the Umeh volcanic complex. It means the location TPS1 and TPS8 near from the heat source. This is a pressure and temperature data from the borehole. The well that is directed just below the UFC, LSDA, around here, show a higher temperature than production well in LSDB, around here. The temperature in LSDA reaches until 300 degrees C, and LSDA has thick convective zone like this. Compared to the temperature in the LSDB, the temperature LSDB around the 250 until 275, and at the deeper, we can see like reversal pattern like this. The location of the LSDA farther from the main heat source is Sempu compared to the location of LSDB around here. But the temperature from LSDA higher than the temperature in LSDB. It means the location of LSDA possible has near from additional heat source. This is the conclusion for our research. The heat source beneath Umeh volcanic complex can identify the one circular feature on the top of Mount Umeh that looks like a small crater in remote sensing data. So it's possible that location beneath Umeh volcanic complex has additional heat source. And number two, the content of deuterium and oxygen-18 from the manifestation on UFC, TPS1 and TPS8 shifting to the magmatic zone. And number three, present updoming pattern in resistivity and high anomaly gravity in the beneath Umeh volcanic complex. It means the location, this location possible has additional heat source. And based on the temperature from LSDA, higher than the temperature in the temperature in LSDB. The location LSDA farther from main heat source Sempu volcanic complex compared to the LSDB, but the temperature higher. This means the location of the LSDA possible near from the heat source. Thus it could be interpreted that there was a heat source under UFC manifestation complex. Thank you very much.
Okay, thank you, Mr. Sigit Suryanto. Very nice presentation. And we now continue with the question and answers part. First question from Claudio. Based on the results of this study, it could be interpreted that there was a heat source under Umeh volcanic complex. The question is how the future development strategy for this situation. Any plans for drilling a new well? So, and then he continued the question from wellbore data, the Umeh show higher temperature compared to LHDA. Is there any possibility of a structure separating LHDA and LSDB? So that's the first question from Claudio Pangohong. Okay, please answer, Mr. Sigit Suryanto.
Thank you, Pak Iwan, for the question. I try to answer that question. Number one, we will study about the prospect in Umeh volcanic complex, and we need some additional data to make sure the location of the heat source is the first time, and after that we need well production test, because the wells around the Umeh volcanic complex until now cannot be production test, due to social problem. So that means we have planned to develop this area, but prior to take decision to develop this area, we need some additional data to make sure the prospect in this area. And the second question, Pak Irwan, I try to answer. As information, we already run a tracer test in Tompaso geothermal field. The purpose of the tracer test, we want to know the structural boundary, or the the structure with the low permeability can as like a boundary between Umeh volcanic complex and the reservoir production in around LSDB. And to determine that, we need some additional data too, to make sure the compartment from the Umeh prospect or the existing prospect.
Okay.
That's all, Pak.
Okay, thank you. That's the first question from Mr. Claudio Pangohong. And the second question from the audience, from Mr. Permadi from ITB. He asked, how are the characteristics of manifestation in Umeh volcanic complex? Maybe the characteristic of the thermal manifestation, right?
Thank you, Pak Permadi, for the question. There are several types of manifestation around Umeh volcanic complex, like fumarole, steam heated manifestation, mud pool, and boiling chloride spring. And NCG from geothermal manifestation around Umeh volcanic complex slightly higher than the surrounding area. And the presence of fumarole, acid sulfate manifestation, boiling chloride spring in the same location, or the distance each other approximately or less than 500 meters. It's been around UFC possible has additional heat source, I think. I hope my answer can make him satisfied.
Okay, Thank you. Next question, the third question from the audience is from Miss Rios from Kyoto University. Thank you for your presentation. Does the reversal temperature in LHDB refer to the recharge influx to the system? She asked, there is a connection, the recharge flux to the system from LHDB.
Yeah, thank you for the question. This is being studied by my team. We still need some additional data like maybe PTS flowing and other reservoir data to determine that to answer or to determine that condition. And yeah, we still need some additional data to make sure that condition.
Okay, thank you. The last question in this session from Miss or Mr. Marin Brehme from Germany, I think. How are Mount Soputan and Ume volcanic complex related? Are they one magmatic complex?
Okay, thank you, Marin Brehme. I think this is a different condition because the Mount Soputan is related to the recent subduction zone in Molucasi, but Ume volcanic complex, I think different magma chamber, and based on this condition, we still need some several study like its dating to make sure the volcanostratigraphy maybe between the Mount Sempu and Mount Ume. I think enough, Pak.
Okay. There's a question again from Mr. Marino Baruk from Supreme Energy. Temperature in LHDB showed convective profile. Did you encounter good permeability while drilling this well? Marked, for example, by low circulation? Are there any sign of low circulation?
Okay, yes, the convective profile in LHDB related to the TLC zone in LHDB in measured depth around the 1,100 meter. We got a total of circulation until bottom of the wells.
Okay, good. Very nice answer and question and very fruitful discussion. So that's all from the third presenter, Mr. Sigit Suryanto. So we give very warm applause to him. And then, thank you, Mr. Sigit Suryanto. Before we move to the next speaker, fourth speaker, we will see the video from our sponsor from Scientific Drilling. Okay, Thank you, ladies and gentlemen. We meet again. So now we are going to move to the next speaker, Ms. Fauziah Maswah from ITB. Okay, Ms. Fauziah Maswah from ITB. His educational background is graduate from Hasanuddin University, and now she involved in the internship at Geological Agency, Ministry of Energy and Mineral Resources, Bandung, start from 2016. Okay, Ms. Fauziah Maswah, time is yours for presentation.
Assalamualaikum warahmatullahi wabarakatuh, and good afternoon, everyone. My name is Fauziah Maswah, and I'm from Geothermal Master Student, Bandung Institute of Technology. At the moment, I will present my research paper about magnetotelluric data analysis using phase tensor and tipper strike to determine geoelectrical strike in geothermal field. First, I want to explain why we have to know about this data analysis in magnetotelluric. Okay, a magnetotelluric method is passive geophysical method that measure natural electromagnetic field to estimate the subsurface resistivity structure. This method is powerful in geothermal exploration because there is the relationship between the temperature effect to rock formation and mineralization with the conductivity or resistivity. This method can also determine the geometry of the subsurface based on the conductivity or resistivity characteristic. But to increase understanding about the subsurface, it's developed from a comprehensive and high-quality data analysis. So, before we conducting to the empty data inversion, data analysis, including determining the geoelectrical strike direction, should be performed. It's because there is an assumption should be fulfilled. The empty data have to be rotated to the geoelectrical strike direction before we perform to the empty data inversion. As shown in this figure, this is a simple 2D model with a vertical contact generated by Simpson and Barr 2005. In 2D earth structure, the resistivity changes in depth and one of the horizontal direction, X or Y. And as we can see in this model, the resistivity changes in a Y direction and separated by the vertical contact. The constant resistivity of the other direction, I mean the X direction, are called the geoelectrical strike. And therefore, in 2D empty data inversion, the electromagnetic field can be decoupled into two independent modes by rotating the empty data to the geoelectrical strike. It is E-polarization and B-polarization. E-polarization, when the electrical field is parallel to the strike, and B-polarization, when the electrical field is perpendicular to the strike. So first, we have to obtain or to determine the geoelectrical strike direction before we perform to the empty data inversion. And we use phase tensor and tipper strike parameters to identify the geoelectrical strike in the subsurface. Okay, proceed to the next slide. Okay, the electrical field and magnetic field from the empty measurement are used to calculate the impedance, and the ratio of the real and imaginary part of the impedance are called phase tensor, and it contains the information of the geoelectrical strike direction in subsurface. Since the phase tensor contains the 90-degree ambiguity, we use Tipper strike to resolve it, and it is calculated from the vertical component of magnetic field and generated by a linear combination of horizontal magnetic field. Okay, proceed to the next slide. This is the geological structure map of the area, and as we can see, it shows the complexity structure in the surface. The geological structure developed in the area are dominated by north-south, northwest-southeast trend, and northeast-southwest trend. This information of the geological structure is used to confirm the result of the magnetotelluric analysis. I mean, Tipper strike and phase tensor. Okay, proceed to the next slide. We applied 25 empty sites to investigate the geoelectrical strike of the area. And the distance between the sites varies between 500 until 1,000 meters. Okay, we analyzed the phase tensor and Tipper strike formulated in Python, and the result of phase tensor and Tipper strike are plotted to a Ross diagram to know the dominant geoelectrical strike of the area. And we use the information from the geological structure to confirm the result from the phase tensor and Tipper strike. And as we can see, the result from phase tensor and Tipper strike show the consistency of the geoelectrical strike in northeast southwest direction, and confirm with the geological information, I mean the geological structure of the area. We found that the dominant geoelectrical strike is estimated at north 15 degrees east, and the result shows a good correspond with the northeast southwest trend regional structure of the area. Okay, I'll proceed to the next slide. We also identify the dimensionality of magnetotelluric data from 14 empty sites, and we use Q angle parameters from phase tensor. The result shows the majority of magnetotelluric data in short period, I mean in the shallow part, suggesting evident 1D or 2D structures, and it characterized by the low of the skew value, as we can see in the light color. And meanwhile, the long periods or the deeper part, the empty data show the 3D structures, and it characterized by the large of the skew value, as we can see in the dark color. And we found that the deeper part of the area, it indicates the complexity of the structure in subsurface. We identify the dimensionality of magnetotelluric data to better understand about the subsurface characteristic. And from the analysis, we conclude that the result shows 1D or 2D structure of the magnetotelluric data in short periods. Meanwhile, the long periods, majority of the magnetotelluric data show 3D structure. We also found that the dominant geoelectrical strike is around north 15 degrees east, and it is confirmed with the regional structure of the area. And last but not least, I would say my highest appreciation for PT Geodipa Energi Persero, which supported and provided the magnetotelluric data, and the authors benefit fruitful discussion with Mas Angga from Geothermal Master Program, Kak Desi, Kak Anggi, and Mas Pesta from Art Physics Department. The authors will also like gratitude to Modeling and Inversion Laboratory and Geothermal Laboratory. Thank you very much.
Okay, thank you, Ms. Fauziah Maswah, for your very nice presentation, and you show very clear your method. You show us the very clear method, and there are some questions from the audience. The first question is from Alfiat from Universitas Pajajaran. What is the benefit of rotating MT data related to the geometry of the subsurface? So that's the first question.
Okay, thank you very much, Pak, for the question. The benefit of this method is MT modeling after rotation result a better resolution of the subsurface geometry and can avoid the misinterpretation. And also some of research previous research said that the MT modeling after rotation make the anomaly zone in the subsurface become strong or weak depend on the characteristic of the resistivity in subsurface.
Okay.
I think that's it. I hope it can answer the question.
Okay, thank you, because you have so many questions here. And the next question is from Juni from PT Sumbawa Timur Mining, STM. Can you explain the relationship between the geoelectrical strike and geological strike? What is the concern about your method to obtain the geoelectrical strike?
Okay, thank you for the question, Pak. The difference between the geoelectrical strike and geological strike. Okay, the geoelectrical strike is a direction that present the orientation of the electric current flow continuously. And some previous research said that there is a relationship between the geoelectrical and geological strike. Some previous research said that geoelectrical strike have the same pattern with the geological strike, particularly when there is elongated conductor that electric current field can flow in this direction. Related to the geological condition, such as there is a geological structure such as normal fault or strike slip fault with the opening, and this probably this fault is permeable, so permeable with fluid filling or maybe the mineral alteration. This fault is good for the fluid pathways, and this fluid pathways is a good medium for electric current flow in this direction. That's why the geoelectrical strike have the same pattern with the geological strike. I think that's it. I hope this answer can
okay, very nice question. Very nice question and very clear answer. And the third question is from Irfan Ramadan, Supreme Energy. Thank you for your good presentation. The question is, do you compare the results from fast tensor method with the bar skew and sweep skew methods?
Okay, thank you for the question. Actually, in this research, I didn't use bar skew and sweep skew, but maybe for the further analysis to convince the result from my analysis, it can be used. I think that's
okay. And then the next question from Zulinira from ITB. What are the advantages of this method, and what is the consideration did you make in analyzing the result of this research?
Okay. The advantage of this method is for phase tensor. Phase tensor is not affected by the galvanic distortion. And the second is this method can analyze the magnetotelluric data for each signal period. So we can see we can get the information about the subsurface accurately. And then also this method can analyze the magnetotelluric data over the depth or vertical structure and over the station or lateral structure. And I think for the tipper sec can resolve the ambiguity for the phase tensor. And as we know that the tipper sec can show the lateral conductivity variation, so that the tipper sec can show the conductive zone that may related to the geothermal that may related to geothermal system in the subsurface.
Okay.
And the second is the things to be concerned that as we know that the phase tensor have the ambiguity, the 90-degree ambiguity, so we need another parameter to resolve it. And also from the tipper side, the tipper can show the lateral variation, the conductivity lateral variation that may not which is not related to the geological structure in the subsurface. So we need the information like the geological map to confirm the result.
Okay, Ms. Fauziah, we still have 4 questions, but you have a very limited time. Maybe you can answer the question in very short answer. From Daniel, how do you determine the empty survey point? There are some of the structures that didn't cover. So you can say, yeah, very short answer.
Okay, I think for the empty station, it is I just used a 25 site, and it is related to the data provider.
Okay, because we have a very limited time, and the time is up. There are still 3 other questions from other participants, so we can close this session. Very nice presentation and discussion. We give applause to Ms. Fauziah Maswah. Thank you.
Thank you very much, Pak.
Thank you. And before we go to the next speaker, to the 4th speaker, now we can see the video from our sponsor, Pelumpang Raya Anugerah. Thank you. Okay, thank you, ladies and gentlemen. We're back in this very nice technical session of the second day of ITB International Geothermal Workshop 2020. So we will go to the fifth speaker of this session from Miss Betseba Sibarani from ITB. He got the bachelor degree in geological engineering ITB. And now he is a lecturer at Geothermal Master Program of ITB, start from 2019 and till now. So, time is yours, Miss Betseba Sibarani, for presentation.
Hello participant of ITB International Geothermal Workshop. Let me introduce myself. My name is Betseba Sibarani from Geothermal Master Program of ITB. On behalf of other occurrers, I will present about our research. Our research is about geological control on thermal manifestation occurrences in Batu Gede and Batu Kapur based on the result of a preliminary survey. This is the outline of my presentation. I will start with introduction, data and method, tectonic setting, and regional geology, and then discussion including geology and geochemistry, and close with conclusion. This map showing the location of research area. Batu Kapur and Batu Gede are two areas located in Subang Regency, West Java Province, around 13 to 15 km from the northern part of Tacubang Perahu volcano. These two areas are 5 km away, which is not too far. In general, manifestation in these two areas are generally characterized by the presence of bicarbonate warm springs with a natural pH. Despite the similar characteristic of their manifestation, there is a significant characteristic difference between them. Acidic pH cold spring with pungent smell of sulfur with mud pool and acid alteration emerge in the Batu Gede area. What is the cause? What is the geological control? Geological control like permeability, host rock, and heat source will affect the emergence and also characteristic of the manifestations. In this research area, as a preliminary, we focus more on permeability that act as the controller of the occurrence of manifestations. Permeability consists of primary permeability and secondary permeability. We will confirm which permeability control the occurrence of manifestation in both areas. Based on that background, this research is aimed to determine the control of geothermal manifestations at Batu Gede and Batu Kapur area by conducting preliminary geological study with additional geochemical data from anomaly manifestation. Data that we use are from literature and field data. Literature data consists of regional geology, tectonic setting, and water geochemistry, and field data consists of outcrop including lithology and structure, and geochemistry of manifestations. Petrography analysis is also conducted to confirm the lithology, while geochemistry of manifestation is collected from acid cold spring sample. To understand the occurrences of Batu Gede and Batu Kapur geothermal manifestations, geological mapping has been conducted. The basic framework is to comprehend the correlation of the occurrence of manifestation with drainage pattern, slope, and catchment area. Lithology, whether the manifestation only emerged in a certain lithology or in a lithological contact. Geological structure, to find structure evident along manifestation, to see manifestation discharge. If the flow rate is high, manifestation would be highly influenced by structure. Its own distribution and characteristics such as dimension, bubbling distribution, and alteration. Geochemistry analysis on manifestation is also been done, with warm spring manifestation is referenced from Fauziah et al. 2015 and cation-anion analysis on cold spring manifestation water sample. Java is located at the southern part of the Sundaland of Eurasian Plate, where the Indian-Australian Plate is subducted beneath Eurasian Plate. West Java is considered to be located in the transitional zone between oblique subduction in Sumatra and orthogonal subduction at the eastern part of West Java. Regional lithological units that present in the study area from older to younger respectively are Kaliwang Formation, Citalang Formation, older volcanic product, pumiceous tuff, old volcanic product lava, and alphium. In the southern part of the study area, less old volcanic product lava, pumiceous tuff, and older volcanic products. undifferentiated young volcanic products found in the middle area. These are eruption products of Tangkuban Perahu volcano located in the south of the study area. The northward area is dominated by Citalang and Kaliwangu Formation. Kaliwangu Formation is indicated as marine sediment, corresponding with the presence of calcareous sandstone and limestone. Kaliwangu Formation has regional dipping direction southward, approximately 10 until 29 degrees. It can be interpreted as proof that Kaliwangu Formation can be found below the study area. Kaliwangu Formation's bed is relatively thick on east, thinner on the middle area and getting thicker eastward. This condition causes the occurrence of travertine on Batu Kapur is more than Batu Gede. Remote sensing geomorphology is one of the important things to observe the control of the occurrence of manifestation. This is part of the pre-field work. What we will observe here is the drainage pattern, slope, and catchment area. From these three analyses, we will briefly discuss matters that relate directly to the control of manifestation. Following is the drainage pattern map of Batu Gede and Batu Kapur. In summary, both areas are dominated by a rectangular pattern as an indicative of streams following prominent fault or joint system. At Batu Gede, particularly around manifestations, there is a significant change of the slope, where the gently area is surrounded by steep area. It might indicate the presence of fault or lithological contact. Manifestation emerge in gentle slope, therefore it might be associated with fine-grained size rock or basin or graben. Meanwhile, Batu Kapur is included in the relatively steep hills unit. It seems to be associated with fault structure that were inferred from topographical offsets, river alignments, and steep slope alignments. Origin of the catchment area is from the flank of Tangkuban Perahu in the northern part of research area. It indicates that the regional flow is still getting effect from Tangkuban Perahu. However, from detailed observation, Batu Gede's manifestation in reality is not directly affected by Tangkuban Perahu. The flow direction of Tangkuban Perahu product is obstructed by a ridge that becomes the boundary of Batu Gede's subcatchment. The manifestation is concentrated in the main valley of the subcatchment. Flow direction is originated from a narrow ridge. These facts indicated that Batu Gede is structural control manifestation. Meanwhile, Batu Kapur manifestation flow clearly originates from ridge lineament with trend northwest-southeast and west-northwest-east-southeast. This shows that Batu Kapur is correlated with heat flow with a source from a certain depth. Lithology can also control the occurrence of manifestations. In this section, we will discuss about the key findings that can significantly affect the occurrence of manifestation at both areas. Based on field mapping, lithology in the research area mostly consists of volcanic rock like andesite, basalt lava, crystal tuff, pumice-rich pyroclastic breccia, vitric tuff, lapilli tuff, volcanic classic, and sedimentary rock such as claystone, sandstone, and limestone. From this geological map, we can see that these two manifestation clusters are located in the transition environment between volcanic product of Tangkuban Perahu and sedimentary rock that indicated with the presence of volcanic clastic and unmappable limestone. For more detail, we will discuss the evidence that found in the field. Lithological contact between pumice-rich pyroclastic breccia and lapilli tuff is found near to acid cold spring manifestation of Batu Gede. This contact is thought to become the control of alteration that is affected by water table. Pumice-rich breccia is thinning to the northwestern part, while lapilli tuff is thickening. Mud pool and low pH cold spring might be controlled by lithological contact and current water table. Mud is easier to form, especially in fine-grained size rocks. Pumice-rich breccia contact with volcanic clastic was observed near Batu Kapur, where volcanic clastic is exposed in the lower part. There is charcoal layer between the contact. This contact can be assumed as a permeable zone. The occurrence of volcanic clastic became an indication that this area is part of a distal facies. The appearance of volcanic clastic is also supported by the presence of piszoid texture. This shows that research area is in the transition environment where volcanic rock meets the sedimentary product. This becomes a contact that can be a permeable zone. The presence of this rock is also indicated that at greater depth, host rock of reservoir might be controlled by marine sedimentary rock, which is Kaliwangu Formation. Similar with Batu Gede, contact of ignimbrite and volcaniclastic was also found at Batu Kapur. However, volcaniclastic at Batu Kapur is found at the lower elevation, covered by very thick ignimbrite product. Around Batu Kapur manifestation, spotted limestone containing mollusca was also exposed. This rock is thought to originate from Kaliwang Formation, which is a marine sedimentary formation formed in the shallow marine. By looking at the evidence of Kaliwang Formation presence, volcaniclastic as well as the very thick ignimbrite product, the area around Batu Kapur might be associated with sedimentary basin. This should be confirmed by conducting further study such as geophysical survey. Aside from lithology, fault also has an important role in controlling the occurrence of manifestation. Fault is interpreted controlling the manifestation when evidence of fault are found in the vicinity of research area, especially around the manifestation. Following are the evidence of fault that was observed in the field. Following is geological structure map of the study area. We can see that the Batu Gede area is cut by sinistral strike slip fault that results in overstep structure around the manifestation, while Batu Kapur area is cut by relatively north-south and west-northwest east-southeast direction fault. For more detail, we will look at evidence found in the field. Overstepping structure in the Batu Gede area is also supported by the appearance of its morphology, where manifestations are in the flat morphology flanked by steep morphology. Following is the example of overstepping structure that was observed in the field. This is also supported by petrographic analysis that shows overstepping structure in thin section. Following are the evidence of structure that was found along the Batu Kapur River consists of silicon site, fault plane, and offset showing the sinistral strike slip fault. This fault is interpreted as antithetic fault that cut fault with north-northwest, south-southeast direction. The last thing to be discussed is the distribution and characteristic of manifestations found in the field. In this section, we will look to what extent the distribution of manifestation in the study area. At Batu Kapur area, thermal springs and abundance of travertine are found along the river. This slide shows the characteristic manifestation dominated by relatively warm spring with neutral pH and high flow rate. High flow rate shows the indication of fault. At some areas, there is warm spring that emerge from lithological contact. That lithological contact is thought to be not too dominant permeable zone in the research area. The emergence of travertine and intense bubbling indicate that reservoir in the subsurface is controlled by rock from Kaliwang Formation. From this sketch, we can see that manifestation around Batu Kapur is controlled by intersection of north-northwest, south-southeast, and west-northwest, east-southeast strike slip fault and lithological contact. Furthermore, we will discuss manifestation in Batu Gede. This map showing manifestation with relatively warm temperature, neutral pH, and high flow rate. However, there is anomalous manifestation that occur in the surface in the form of mud pool and acid cold spring. Following is the distribution of alteration and bubble in the Batu Gede area, where the distribution is only centered on the stepping structure, as shown in the sketch. Following is the appearance of mud pool with a dimension of 40 x 70 cm. There is acid alteration with the presence of sulfur and pungent odor smell around it. Next, we would discuss about geochemistry of Batu Gede and Batu Kapur. Warm spring geochemical data, a reference from Farrozi et al. 2015, while cold spring geochemical data are primary data about geochemistry of Batu Gede and the high content of chloride is also followed by the contents of sodium and bicarbonate. Well, this is thought to be related to the formation of marine sediments beneath the surface from Kaliwang Formation. Meanwhile, acid cold spring manifestation in Batu Gede contain high concentration of sulfate. This could be related to condensation the hydrogen sulfide underground, indicating the possibility of subsurface magmatic activity. Conclusion of this research are both of Batu Gede and Batu Kapur area are dominantly controlled by secondary permeability. Batu Gede manifestation is controlled by overstepping structure, meanwhile, Batu Kapur manifestation is by intersection fault. Based on a high sulfate content, appearance of acid alteration and sulfur, acidic cold spring in Batu Gede might be associated with magmatic activity beneath the surface. The last is to confirm the subsurface magmatic activity. Further research such as gravity and gas geochemistry analysis need to be done. This is the end of my presentation. Thank you for your attention.
Okay, thank you, Ms. Betseba Sibarani, for your nice presentation. So, very nice result. And we have some question and comments. First question is from JJ from ITB. Can manifestation of batu gede and batu kapur be interpreted as the outflow of Tangkuban Perahu geothermal system?
Okay, thank you for the question, Pak Irwan. So from previous study mentioned that batu gede and batu kapur manifestation are outflow part of Tangkuban Perahu. This seems to be based on type of manifestation such as warm spring with natural pH and bicarbonate water type, and also their occurrence which is at the foot of Tangkuban Perahu volcano. However, it seems strange that the emergence of anomalous acid manifestation along with sulfur is considered as an outflow. The presence of sediment on the surface around batu gede and batu kapur indicating the different geological condition between them and Tangkuban Perahu volcano. It also causes this manifestation to have an excess of chloride, bicarbonate, and sodium composition. Therefore, to ensure it, we need to look at the geochemistry of gas and cold spring between Tangkuban Perahu volcano and Batu Kapur and Batu Gede area.
Okay.
Hope my answer covered the question.
Okay, thank you, Ms. Betseba. We move to the second question from Prayolandini from ITB. As far as I know, there are ciracas in the western part of Batu Gede. Is the control of its formation the same as the other two manifestations?
Thank you, Mbak Yolan. Actually, ciracas manifestation are outside of our study area. The manifestation characteristics are still the same, namely bicarbonate warm water, and its appearance may be controlled by relay ramp structure. However, to know the relationship between them, it needs to be investigated further. Thank you.
Okay, thank you. For the third question, is come from Aris from University of Brawijaya, UB, I mean. What alteration types responsible for Batu Gede manifestation?
Okay, thank you, Aris. Based on the characteristic, where found white color clay, powdery, and some muddy with acidic pH water, the mineral is interpreted as kaolinite. Alunite is possibly could be found here, but for alunite, confirmation by XRD analysis is needed. Moreover, around the acidic manifestation also found pale yellow color sulfur. However, additional isotope sulfur data is also important because it explains the source of sulfur.
Okay, thank you. For the fourth question from Andrew from Universitas Negeri Manado, which geochemical study you prefer to be conducted in the area?
Sorry, Pak?
Which geochemical study you prefer to be conducted in the area? I mean, what type of geochemical study?
Oh, okay. Thank you for the question. Based on manifestation finding in the field, the geochemical study to be conducted is a study of the chemical characteristic of water and gas, including isotope and dissolved chemical element, cation or anion. This aims to determine the fluid origin, common source, reservoir, and magnetic heat source activity. Geochemical analysis of cold water is needed to be conducted. It aims to estimate the boundaries of the system.
Okay, thank you. For the fifth question from Claudio from Thermochem Indonesia. could you emphasize or explain more about overstepping structure in your study area?
Yeah, thank you for the question. So the Batu Gede is the manifestation of Batu Gede is controlled by overstepping structure. Overstepping fault in our research area is generated by overlapping structure fault. This overlapping structure generates extension or relay RAM. In this research area, the evidence of stepping fault is found in basalt rock. Thank you.
Thank you, Ms. Betseba. For the sixth question from Rios from Kyoto University, could you give a brief explanation about the term of transition area from piszoid texture?
Oh, okay. Thank you for the question, Mbak Rio. So, our research area is located between in transition. Our research area is located in transition area, which is there are volcanic product. We found volcanic product and also sedimentary rock unit. Sedimentary rock unit is also confirmed by piszoid texture, or maybe we usually call it ooid. It is a texture in carbonate rock.
Okay, thank you. And next question, the seventh question from Saifuddin from QC University. So you have many fans from other overseas universities. Are the faults related to the extensional or compressional setting? What is the suspected magmatic activity? What is it related to Tangkuban Perahu? So that's the question from Mr. Saifuddin.
For the first question, the structures actually related with extension in relay RAM. So relay RAM is extension that generated by overlapping structure, and the structure control the permeability of Batu Gede area, and also the magmatic source. I think we need to investigate it further about that, because there is many ambiguity about the appearance of magmatic here, but we found sulfur acid alteration and also acid pH of water in Batu Gede. So I think we need to conduct the geochemistry survey, like analyze the cold water sample and also gravity to emphasize the source of magmatic is from Tangkuban or not.
Okay. Okay. The next question comes from Vero, Universitas Negeri Manado. Where should a geophysical survey such as gravity be carried out? Can you show us the areas that can be done geophysical survey to support your research? That's a question from Vero.
Sorry, Pak, could you please repeat that?
Maybe where should a geophysical survey such as gravity be carried out? The location, of course. Can you show us the area that can be done?
Oh, okay. I think the gravity is important to conduct it in this area to confirm the structure, so we can use horizontal derivative gravity, and also we can use the gravity for predict or interpret the sedimentary basin in this area. And I think we can use the gravity in Batu Gede and Batu Kapur manifestation, and also Ciracas manifestation that I mentioned before.
Okay, Okay, thank you for the answer. Actually, we have some another questions from the audience, but the time is up, so we should close this session of your presentation. Maybe the other audience can directly ask question to Ms. Betseba Sibarani. Okay, very fruitful discussion. Give applause to Betseba Sibarani. Okay, thank you, ladies and gentlemen. So before we move to the last speaker, we can see another video from our sponsor, from Kogindo.
PT Kogindo Daya Bersama adalah perusahaan ketenaga listrikan di Indonesia yang beroperasi di seluruh wilayah Indonesia dari Sabang sampai Merauke. Kogindo didirikan pada tahun 1998 sebagai anak perusahaan PT Indonesia Power dan bagian dari PT PLN Persero. Kogindo memiliki 4 bidang usaha, yaitu suplai energi, jasa operasi dan pemeliharaan pembangkit listrik, jasa gas dan diesel engine, dan jasa maintenance, repair, overhaul, MRO. Dalam kurun waktu lebih dari 2 dekade, kami telah mengembangkan bisnis kami secara signifikan dan membangun dasar yang kokoh bagi portofolio perusahaan di level nasional maupun internasional. Kogindo menawarkan satu solusi layanan terintegrasi di bidang ketenaga listrikan melalui Kogindo Integrated Solution. Dengan menggabungkan kompetensi, teknologi dan pengalaman, kami yakin dapat membantu para pelanggan mencapai efisiensi dan keandalan pengoperasian pembangkit listrik di Indonesia dan seluruh belahan dunia. Kogindo, Trusted Partner.
Okay, thank you, ladies and gentlemen. Now we move to the last but not least, our speaker today on the ITB International ITB Geothermal Workshop from Mr. Ghilman Azka. Mr. Ghilman Azka is a field chemist at PT Supreme Energy Muara Labuh. Okay, Mr. Ghilman Azka, now time is yours for your presentations.
Hello, everyone. Well, today I'm going to explain a little bit about black material deposition in surface facilities during commissioning in Muara Labuh Geothermal. This is going to be a short presentation, because it's not going to be complex or sophisticated. I'm not going to go into detail. I'm not going to explain anything about thermodynamic, the dynamic of the fluid itself, but I'm more into getting people to be aware of the black material occurrence during the commissioning program and how was it formed based on our analysis using the SEM and EDX. So this is me, Ghilman Azka, field chemist from Supreme Energy Muara Labuh, and Alfiadi as order, and as a geochemist, and Herwin Aziz as a chief development geologist, and Mauliate as a geochemist as well. Let's just get on to the presentation. And this is the outline of the presentation. I'm gonna have a little bit not discussion, I'm gonna explain a little bit about the geothermal power plant and more of an overview. And then the problem prior to COD. Prior to COD, we have this pre-COD program, such as pre-commissioning and commissioning. And then during the pre-COD program, we have this problem, big issue back then, black material appearance in steam above ground system. Then we took the sample, and I'm going to show you the result based on SEM EDX. For that, we're going to deduct the probable source of the black material and a little bit of summary. I'm not going to put any conclusion there because I haven't put any point out objective, so it's better to put the summary. For me, it's just a matter of principle. If there is no objective, then there will be no conclusion within the paper. So this is the first geothermal power plant that has been operational for about 6 months, 6 to 7 months till July. And in West Sumatra, located in Solok Regency, I didn't put any map there because it's quite easy to find. If you search it, Google, you put Solok Selatan name there, you're gonna find the regency, and you type another word such as geothermal power plant, you're gonna find the location is quite easy to find. And then we accomplished commissioning operation date on 16 December 2019. It's been operational for 7 months till July 2020. The generation itself, well, 80 to 85 megawatt electricity net, depends on PL and demand. So maximum 85 megawatt. So prior to COD, the plant underwent several major steps such as pre-commissioning and commissioning program. We call this a pre-COD program. So the pre-COD program also consists of a steam blow, step 1 to step 3, and then also the pre-commissioning, which are called the parameter, and also the electrical sort of stuff, and the commissioning, including the RR test work. And then we did a generation for about 1 month, see how it went. It went quite well, despite the fact that we encountered some problem, such as black material appearance. The other problem also error reading, not really a big issue, but this one, it was a big issue back then. And this is the power plant overview. So we have a HP line, high pressure line, and LP or low pressure line. The HP dedicated for a HP well or high pressure well separated on their own. HP separator goes into HP section of the turbine. On the other hand, LP separator, the fluid comes from the flash brine of the HP fluid, and then also mix with the LP, the LP source of the from the well. So mix together, get into the LP separator, and then goes into the same turbine as the HP steam. So HP and LP go into the same turbine, and the rest is quite similar to the other conservative geothermal system. We have this condenser, direct contact, and then the cooling tower to cool back to the condenser. And some of the steam condensate will be injected back to the reservoir. We have this condensate injection well. It differs with the brine injection well. So this is a hot brine injection well. And then during the commissioning program, we encountered some black material, such as beneath the HP separator drain, and then the LP separator, and then the CDP or condensate drain pot, and HP scrubber drain, and also HP strainer turbine. Also, surprisingly, we also encountered the black material within the cooling tower basin. It was quite surprising because could have been damaged to the turbine. So it went through the turbine and could probably damage the turbine itself. Wait a minute. I gotta turn off the video. It's quite noisy. There we go. So where was I? So the black material actually went through the turbine and went to the cooling tower. So the real question is, how was the turbine condition when the black material went through the turbine? So plenty of location for the black material itself. We encountered plenty of location, but I only show you some of the results from the HP separator and the HP scanner. We're gonna see how different it is for both of them. This is the physical appearance from the condenser drain pot. As you can see, it is really very grain, very fine grain, blackish and reddish, probably some rust in it, or it is really rust. And then this is from the strainer of the turbine. It has magnetic property. And this is the thermal pond. Thermal pond actually from the condensate mostly. So from the CDP, they go to the AFT of the condensate, go to the thermal pond. As you can see here, the water from blue turned into black, some part of it. And this one, it's in the cooling tower basin, turned into completely black. So we have to shut down during the commissioning program because of the clogging at the turbine strainer, and we have to wash all of it. It's the fact that it was black. And then some sample taken to ITB to be analyzed with SEM EDX. This is the result from the HP, and this is the result from the turbine strainer. You can see some difference there. First, the HP separator got silica, arsen, and calcium peak. Meanwhile, on the result for the turbine strainer, it doesn't show us any calcium, silica, or arsen. Silica and arsen and also calcium could have been a product of debris from the well itself, but it has been separated beneath the separator. While the turbine strainer, the sample from the turbine strainer, it shows us consistent of a peak of iron and also sulfur. I still don't know why gold is also present there, but I still don't have the answer for that. Coating, I'm not sure why there is gold peak there. So mostly the EDX result consists of iron and sulfur and also oxygen. And if we kind of have this kind of X-ray, we will see it was pure iron sulfide, dominantly iron sulfide. This and we go into the probable source of the black material. You can see here that the black material stays beneath the bottle. So the density of the black material is bigger than the steam condensate. This is a condensate from HP separator. And this is the picture of a brine. It's a clear image. I'm gonna zoom in a little bit. Yes, you can see the brine. It is really clear. It contain no black material. So the source is not going to be from the reservoir. So two remaining source, casing or surface related. Surface related means the pipe. And then also, if any theory tell us that it's from the reservoir, no, because we also conducted a flowing test for 2 years, and the very fine grain of material never been encountered. So, if it is from the casing, the brine won't be clear as this kind of sample. This was taken during the RR test, reliability run test on, I think, in December 2019. It's clear. So the most probable source of the black material itself, it's from the surface related source. It's from the pipe. And how it was formed? It was formed due to the reaction between condensate that contains some amount of hydrogen sulfide and oxygen. The inner pipe actually reacted with the remaining gases, and it produced the black material. The black material contains iron sulfide of pyrite, and it's likely to happen that way. And also shows the difference between the strainer and also the HP separator sample. So it's not from reservoir, not from the casing. The casing is okay. Probably the remaining rust reacted with the gases. And this is the last page of the presentation. This is a summary. We've been operational for about 7 months with the capacity of 80 to 85 megawatt electricity. And prior to COD, black material encountered within this location, CGP thermal point cooling tower basin. Based on the analysis result, it was mostly iron sulfide or pyrite. And the reaction between inner pipe and also the condensate created that material. There are also 2 questions left, cannot be answered now because period of black material occurrence. It means that when we have the shut-in program and then get the well back online after 2 weeks, 4 weeks, or a month, will the black material occur once more? That's the question we cannot answer right now. Have to see. And then the current black condition after the black material went through the turbine, went to the cooling tower basin. I think that will be all my presentation. And thank you for your attention, and thank you for Supreme as well for giving me this kind of opportunity to present data.
Okay, thank you, Mr. Ghilman Azka. Now we move to the question and answer part of this last session of this today technical session. First, from Abdillah from ITB. Where does the source of the iron? Is it from the formation or from the casing? And what about the gold? That's the first question.
Hello, can you hear me? Because the connection is not stable here.
Yeah, hello,
can you hear me well?
Ghilman Azka. Yeah, I can hear you.
Yeah.
Could you hear
so
me
the
now?
Iron... I can hear you well.
Okay. Is the source of the iron from formation or casing? And how about the gold?
The most probable source of the iron itself is from the pipe, because as you can see from the slide, the brine was quite clear. It is really clear. And during the RR test or reliability run test, we encountered the black material stay beneath the sample. So the density is also bigger than the steam condensate. So the answer is from the pipe itself, because of the reaction between the remaining gas, whether it's oxygen or hydrogen sulfide, that reacts with the pipe. And the gold, I'm not sure whether it is coating material or not, because I've also confirmed with the project that they didn't use any of coating material, but I need to confirm this for a double check. So this is just a SEM EDX, so we only pick one of the sample, and we encountered probably small fraction of gold. So I cannot answer that now. Where does this gold come from?
Okay, thank you, Ghilman. We move to the next question from Albertus from Trisakti University. How can it be deposited by steam, the iron material maybe? Please elaborate on the deposition mechanism. What is in the form of gas before being deposited? So that's the question from Albertus.
As I stated earlier in the presentation, it is actually a condensate, probably beneath the drain pot or even the rust. And then the rust with the condensate also contains some of the hydrogen sulfide. So that's why the peak of the sulfur also present there. So it's a reaction between the condensate and also the pipe.
Okay. Okay, we move to the third question from Rios from Kyoto University. It's trivia question. Have they also found in other geothermal fields in Sumatra or Indonesia in general? Are there any plans to analyze them for trace element?
Trace elements. Well, it is just probably a waste because of the commissioning program. This is basically rust mostly. So we also conducted an analysis with the XRD, and the mineral are mostly pyrit or iron sulfide, magnetite, and also hematite. So this is probably occur in most of the cases during the commissioning. The intention of this presentation is to have awareness of people that this actually occur, and please just stay calm during the commissioning, because it was a big issue back then when this material occurred. So some geothermal plant during the commissioning also encountered this kind of problem, but I haven't found any paper that describing this kind of issue. So I've just heard some of the talk from BGE in Ulublu, and I don't know, Sarula as well probably, but I didn't find any of a reference.
Okay. Okay, actually we still have more questions from the audience. There are more 4 other questions from the audience, but the time is up. Sorry, maybe for the attendees or the participant who sends question, maybe you can directly send question to Mr. Ghilman Azka or to the committee. Sorry for this situation because the time is up. Once again, on behalf of the committee, I said thank you for all the presentation, and for you, very nice presentation and fruitful discussion. Give applause to Mr. Ghilman Azka from Supreme Energy.
Thank you.
Okay, now because all the 6 speakers and the invited speakers already sent their presentation, give the very nice presentation and fruitful discussion, we will close this technical session. But before close this session, I will remind you again, the committee will contact all the presenter regarding your certificate and memento. So the committee will contact you. I revised my first statement in the beginning, and also before I close this session and close to give this session to the MC, Mr. Nira Donald, there is another sponsor from Sustraco.
Geothermal energy is a relatively environmentally friendly source of energy. It is derived from the heat of the earth. In recent years, the market for geothermal power has increased sharply, especially in emerging markets due to the economic growth due to the growing number of communities in low-income rural areas that have access to the power grid. Any governments are also increasing focus to reduce the dependency on expensive fossil fuels and not environmentally friendly. Systraco Group is a company engaged in the energy sector. Established in 1995, Systraco Group is currently very focused to be able to develop and serve you in various needs related to the geothermal sector, which among of them are hole cleaning services. Systraco Group provides comprehensive conventional fishing tools and systems include packer milling and retrieving, internal and external cutting, internal and external engagement, washover, basically every fishing application. Regardless of what's in your well, hence we've removed it successfully. We also provide a radial cutting torch that is safe and without any explosives or harmful chemical elements that can cut the tubular drilling equipment left in the well. As well, biochemical that can scale control, corrosion control, cooling water treatment and also as a rig washer. Downhole camera. Leveraging the advancement of technology today, Systraco Group also provides high-resolution downhole camera equipment and clear image quality and capable of operating up to a depth of 2,000 meters, adding to our line of services to focus on the development of the geothermal sector. Geothermal well testing. Energy Mega Perseda as the sister company of Systraco Group also provides the services of geothermal well testing, real-time well monitoring, geoscience. Digital remote sensing used sniffer 4D drone. Digital remote sensing system has an advanced capability to detect and map for the following energy sector applications: steam surface breakout monitoring, well reliability and integrity monitoring, air quality mapping, well surveillance and inactive well management, geothermal associated gases detector and mapping. All of which are focused to support activities in the geothermal sector. Please, do not hesitate to contact us when you need our support, because we are there for our common progress. Thank you very much.
Okay. Thank you, ladies and gentlemen, for your patience and very fruitful discussion. And now I overhand my responsibility of this technical session of the second day of ITB International Geothermal Workshop 2020. And now Mr. Nira Donald as our MC. Now you are the boss, the owner of this session. Thank you for your participation.
Ladies and gentlemen, first of all, I would like to congratulate Papa Ilwan Iskandar. Let's have again a round of applause to him for great job. Before I wind up these sessions, I would like to welcome all the presenters to open their video camera, please. Betseba, open. Fauziah. Operators, please, let's take a photo together for a record. 1, 2, smile. Thank you very much. I would like also to take this opportunity to thank Mr. Tobias Fischer for his great presentation, and other presenters. They did a great job. Their presentation was very fascinating and very interesting. Apart from that, also, we would like to Thanks all the sponsors who they made a very tremendous job to make this event successful and to finance this international workshop. Thanks goes to our silver sponsor again, PT Sustraco and PT Geodipa Energy. Apart from that, also, I would like to thank the bronze sponsors, PT Tunggal Buana, Utama PT Plumbang Raya Anugrah, PT Scientific Drilling, and Star Geothermal Energy, without forgetting other sponsors, PT Peritama Geothermal Energy, PT Supreme Energy, PT Surana Multi Infrastructure, Kogindo Daya Bersama, De Priwangka, the BNI Bank, and PT Andalatunas Mandiri. Our supporters also, I would like to send our greetings. International Geothermal Association, IGA, Indonesian Geothermal Association, INAGA, as well as Indonesia Association of Geologists. Thank you for your support. And without forgetting our media, you did a great job to broadcast our event. Thanks goes to Think Geoenergy, Geothermal Resource Council, GRC, Madrock Media, thank you very much. Panas Bumi News, thank you very much. And as well, Rambo Energy, without forgetting Indonesian International Geothermal Convention and Exhibition. I would like to remind you again, still we have 2 days left for this International Geothermal Visual Workshop. So do not forget again, tomorrow we have day 3 and the day after tomorrow we have day 4. But as a reminder, tomorrow we're going to have 2 invited speakers. The first one will be the Chief Executive Officer from PT Geodipa Energy, Mr. Ricky Ibrahim, and also we have Jenny Brother Ridge as a senior geoscientist from Jacobs. And again, other 6 presenters, they're going to present their research findings in the field of geoscience. Apart from that, also, I would like to remind you that for those who they didn't present today, but they send their video presentation to us, don't worry, your video will be seen through our official website. Our official website is www.workshop.geothermal.itb.ac.id/workshop 2020. I will repeat again, www.workshop.geothermal.itb.ac/workshop 2020. Don't forget to subscribe on our YouTube channel, because this event will not only be live through Zoom, but as well as we're going to be live in our YouTube channel. So don't forget to subscribe and share to others, friends all over the world. Eventually, time is not friendly. You were with me, Nora Donald, as your master of ceremony today. Second day, please see you somewhere, or we can see you tomorrow on day 3, same time from 3 to 6 p.m. Jakarta time. Thank you and enjoy your evening. Have a nice day.